Today's presentation is about the understanding quadrilaterals. Before talking directly about quadrilaterals, we should know about some basic concepts. They are number one, plane surface. Surface of whiteboard is a plane surface. Surface of the wall is plane surface. The paper is a model of a plane surface. We mean here only a surface. Actually, when you join a number of points without lifting a pencil from the paper, you get a plane curve. So the question is here, curves are of two types. Number one, closed curve. Number two, open curves. The examples are the figures shown under the closed curve. They are closed. The curve which is closed end to end is a closed curve, and the curves which are open at the ends are called open curves. Number one are closed curves, and under number two they are open curves. B. There are two types of closed curves. Now the closed curves, they are also of two types. Number one, simple closed curve. Number two, not simple closed curve. Simple closed curves are the examples or the figures which I have shown under the simple closed curve. The curves which are closed and or not crossed over each other. Number two, under two, the examples are the shapes which have shown in number two that are not simple curves. They are crossing each other at anywhere, so they are not called the simple closed curves. Now we should learn about the polygon. What's meant by the polygon? In fact, poly means many, gon means sides. So the a figure with many sides is called a polygon. Also, the best definition is a simple closed curve made up of only line segments is called a polygon. A figure or a polygon which is only made up of the line segments is called a polygon. That means the closed circle is not a polygon because that is not made up of the line segments. So the curves that are polygons have shown under one para, and the curves that are not polygons because the curves crossed each other. They are not simple curves. Either they are open, either they have crossed over the other sides, so they are not polygons. Polygons are a simple closed curve made up of line segments. Polygons are of two types here on the basis of angles. If we will talk the types of polygons on the basis of angles, then there are two types of polygons, that's convex polygon, number two concave polygons. We have learned in science what is convex mirror and concave mirror. Same is the case with here. So in other words, we can say the convex polygons have a simple definition. I have a simple definition for convex polygons, that a polygons whose all the angles are in the interior are convex polygons, and the polygons whose one or more angles are in the exterior are called concave polygons. B part, more two types of polygons on the base of sides. So when we will talk about the polygons on the base of sides, I mean the measurements on the base of measurement. They are regular polygons and irregular polygons. Regular polygons, a polygon which has equal sides and equal angles, is called a regular polygon, just like equilateral triangle or a square or a five-sided equal measurement, that's called a regular pentagon, a regular hexagon, and also other type of polygon, that's irregular polygon, a polygon which has different size of sides and angles, that's called irregular polygon. So we have the two types of polygons on the basis of measurement of sides, that is regular polygons. They have the equal angles and the equal sides, and irregular polygons are of different sizes of sides and angles. Now the next we want to learn is some of the measures of the exterior angles of the polygon. Some of the measures of exterior angles of any polygon is 360. It is verified. And some of the interior or some of the measures of the interior angles depend upon the number of sides. For example, a triangle has three sides, therefore its sum of measures of interior angles is 180 degrees. Quadrilateral has four sides, its sum of interior angles or 360 degree. Pentagon has five sides, its sum of interior angle is 540 degree. By this we can ascertain a formula to find the sum of the interior angles of any polygon, that is n minus 2 into 180 degree, where n is here number of sides, that should be subtracted by the 2, then multiplied by 180 degree, that is the sum of the measures of its interior angles. So we have another option here, that is we can divide the polygon, any polygon, into the number of triangles. As we know, the sum of the measures of angles of a triangle is 180 degree. For example, if we have a triangle made up of three sides, so there is only a one triangle, so it is sum of the measures of interior angle is 180 degree. Now we have a quadrilateral and a four-sided closed figure. We can divide it into two triangles. So each triangle carries 180 degrees sum of interior angles. Two triangles make together 360 degrees. So we can conclude that the sum of the interior angles of a quadrilateral is 360 degrees. If we have a pentagon, we can divide the pentagon into three triangles. So we can sum up the sum of the three interior angles of three triangles, that is equal to 540 degree. And same is the case with the hexagon. We can divide the hexagon into four triangles and can find the sum of the interior angles of the hexagon, that is 720 degree. If we can use here a formula, that is n minus 2 into 180 degree for a triangle. So there is number of sides are 3, that is 3 minus 2 into 180 degree. 3 minus 2 is 1 into 180 degree, that is 180 degree. If we would talk about the quadrilateral has four sides. If we will use the formula n minus 2 into 180 degree, that is 4 minus 2 into 180 degree, that is 2 into 180, that's 360 degree. And in pentagon there are five sides, that's 5 minus 2 into 180 degree, that is 3 into 180, that is 540 degree. I am talking about only the sum of the measures of the interior angles. In the hexagon there are six sides, that is 6 minus 2 into 180 degree. So that's 4 into 180 degree. That is equal to 720 degree. Now, coming upon the title, that is quadrilaterals. However, this all is included in the understanding of quadrilaterals. That was necessary for we to get the basic concepts of the understanding of quadrilaterals. What's quadrilateral? A polygon which has four sides, four angles, four vertices, four sides AB, BC, CD, and AD are the four sides, and four angles is angle A, angle B, angle C, angle D, and four vertices are A, B, C, and D. Now we will define the quadrilateral as quadrilateral is defined as a two-dimensional shape. It is a two-dimensional shape, that is length and breadth. We have two types of figures in the mathematics, that's two-dimensional and three-dimensional. The two-dimensional shapes are the plane shapes, which are on the plane surface, that is length or breadth, and three-dimensional are those figures which have length, breadth, and height. So we are here talking about only the two-dimensional shapes. So quadrilateral is defined as a two-dimensional shape with four sides, four vertices, and four angles. Now, the sum of the measures of interior angles of a quadrilateral is 360 degree, and also the sum of the exterior angles of the quadrilateral are 360 degree. For interior angles, we can divide the quadrilateral into two triangles. Thus, 180 degree plus 180 degree, that is equal to 360 degree. Or we can use the formula, that's n minus 2 into 180 degree. Here n, that is number of sides, that's 4. So we can use 4 instead of n. 4 minus 2 into 180 degree, that is 2 into 180 degree, that's equal to 360 degree. So the sum of the measures of the interior angles of a quadrilateral is 360 degree. There are different types of quadrilaterals, such as square, rectangle, trapezium or trapezoids, parallelogram, rhombus or rhombi, kite. They all can be discussed in another presentation, inshallah. Thank you.